So one of the significant challenges with bioenergy and one of the great criticisms of bioenergy is that it has the potential to displace land that would be currently used for food production. You know, we all recognize that we face challenges as a planet producing enough food to feed our population. So that's a pretty serious concern. In 2007, the federal government signed into law the Renewable Fuel Standard. And that was to meet a significant portion of our energy needs, particularly liquid fuels, from biomass, from biological sources. And this was done for basically three reasons: to provide a measure of energy security for the nation, to bolster rural agriculture and farm economies, and the reason I'm most interested in it is it's a potentially carbon neutral form of energy. So you're taking carbon dioxide out of the atmosphere through the process of photosynthesis to grow the plant. You take that plant material, turn it into a fuel, combust it, and you put those same molecules of carbon dioxide back into the atmosphere while using the energy to run your automobile. So while you're putting CO2 back in the atmosphere, you're just putting back what was already there. It's a bit of a simplification, but basically it has the potential to provide a low carbon source of liquid fuel for automobiles. Our institute here, the Energy Biosciences Institute, has been working very hard to promote and to understand and develop miscanthus as a perennial crop. Miscanthus is a sterile hybrid, and it comes from Asia. And the reason that's caught our attention is it really produces a lot of biomass. These perennial grasses, miscanthus and switchgrass, are very efficient at recycling their nitrogen. What we did in this study is think about what land might be available for bioenergy production based on economic considerations. So quite clearly, as Champaign County farmer is not going to take his best corn acres and allocate them to a bioenergy crop because it's a less valuable crop. So we used that economic model and we made the assumption that we would just use current market prices to see what land was available. Then we also made an assumption of what if the federal government provided a tax credit. And then we ran a biogeochemical model that told us what the consequences of using that land would be for atmospheric chemistry, greenhouse gases to the atmosphere, the amount of ethanol that was produced. The main finding of our study is that we can meet the renewable fuel standard of producing 32 billion gallons of liquid fuel, and that we can do that without displacing significant quantities of land for food production, and still, without the tax credit, generate a 7% reduction in national greenhouse gases.